My name is Lorenzo Rinaldi from Polimi, and here is a very, very brief introduction to the Calliope framework, which was developed up, I think, 5 to 7 years ago by ETH guys that are now based in TU Delft, which are Stefan Pfenninger and Bryn Pickering. And the Calliope is an open source energy system modeling framework, basically designed to analyze the energy system with high time resolutions. And it's a multi-node model, so it allows also to basically design models with different spatially explicit nodes, and it's also quite user-friendly to let's say also not very skilled programmers. It can be used. Let's say it has a very user-friendly interface to structure all the data, the input data, and as I said, is free and open source. The main focus of Calliope is it can be used in two modes, basically. One is the operation mode and one is the planning mode. The operation mode, as it comes from the name, of course, it's optimizing an energy system, let's say, as a snapshot. So the capacities are given as input, and just the dispatch of the energy that can be not only electricity but also heat or other carriers is optimized with high time resolution. And the planning mode is the opposite. Of course, it's allows to let's say design capacity expansion starting from a period of time and projecting a second period of time. Actually, it's not a let's say dynamic model, but I know that I don't know if by the end of this project the guys will be able to deliver the fully dynamic let's say feature, but for now it's not a dynamic framework. Okay, by looking at the very simple black box of inputs and outputs that Calliope works with as inputs, as I said, different locations are modeled as different nodes. Load demands need to be provided for all the locations, as well as the renewable energy system, the renewable energy sources time series, and the, let's say, the existing technologies available in each location, the transmission lines, cross-border lines. Of course, each technology needs to be characterized with techno-economic parameters, and there can be models also some specific constraints for each technologies. And as output, by using a minimization of the net present cost objective function, we can, let's say, Calliope provides capacity factors, the consumption and production of carriers, the variable fixed and investment cost, LCA for each technology, and in planning mode also the capacity installed of each technology in each node. As a research group, we are, let's say, as we can switch to the model gallery of Calliope, let's say we formulated a couple of models in the model gallery. For example, the one for Kenya, which we use also for teaching activities and teaching seminars that may be useful also for Work Package 6. If I, let's say, just to provide an example, the one for Italy, which was developed by a colleague of us that now is also based in TU Delft. This is an electricity and heat model, and there are many others, as you can see from the documentation. Coming back to the presentation, again, by, let's say, moving to the regional, sectoral, time resolution, and other features. As I said, Calliope works with 1 year time horizon, which can be the present one or a future one, with 1 hour time steps. can operate with operation or planning, let's say, algorithms. And okay, I would skip these 2 points since I just mentioned them. And let's say it has also the possibility to model different scenarios to take into account for uncertainties. In this case, the model takes as input different, for example, demand time series, and provide with a stochastic optimization algorithm the best configuration, a single configuration of the energy system that satisfies all the demand provided as inputs, let's say with a minimum cost trade-off. And as I mentioned, it's a multi-carrier model, allows to model different energy sources, let's say any kind of energy technology that the analyst may find useful. And the geographical resolution is also scalable. So as I mentioned, we developed the Italian model, but I showed you also there is the European model, and there are also district level models. Okay, moving to the key policy relevant questions. I provided a couple of examples taken from some studies that us as a research group or some colleagues of us that now are not in the research group anymore, let's say, worked with. So, for example, as Evelina was saying before, also Calliope, especially in particular, one colleague of us implemented the so-called spores algorithm, which is based on modeling to generate alternatives principle. And as you, oops, sorry. Okay. Sorry for that. I can also switch to this very, let's say, fancy tool that came with the paper. And basically, this is a tool where you can see at a glance by selecting one of these dots different energy system configurations coming out from this work on Europe that are near optimal to the, let's say, they are close to the mathematical optimum, but has a series of different technological characterizations. And this is very useful, we think, for policymakers to have a glance at, to have a look at these kind of a suite of results that may be more practically feasible than the mathematical optimum. So again, let's say I mentioned a couple of other policy relevant questions that can be answered with using Calliope. For example, we can assess the impact of replacement of some technologies that are diffused in favor of an alternative one in a certain region. We can give we can find the best way to find to get to a given emission reduction target by optimizing again the cost of the energy system, or we can answer to let's say energy access related questions. So how to provide access to electricity to a specific region at a minimum cost again. Also, I would be very quick on the SDG relevant linkages. Of course, we mentioned SDG 7 and SDG 13. In particular, we refer to SDG 13 by referring to that work that I showed you before, let's say by showing you the online tool that we developed. Of course, it would be very useful for policymakers. I think these kind of approach are very innovative and let's say they give a twist with respect to the traditional net present cost optimization that maybe, let's say, not so maybe not always the best option. And here is, let's say, a list of references using Calliope. Some are from our group, some are from others. But yeah, thank you for the attention.